Hi everybody, I've had a request to work through the Level 2 2017 Waves NCEA paper and just a couple of questions here. So the question was question 1D. So this is about a 20 centimeter tall candle that's placed in front of a concave mirror of focal length 80 centimeters, and then the candle is moved until the image is upright and 3 times the size of the object. So an upright virtual image is an upright image which is bigger is always a virtual image. So the answer is virtual. Okay, then how do you calculate the object distance, or how far is the candle from the mirror? So I used 3 times is actually the magnification. So if the height of your object is 20 centimeters, then the height of the image will be 3 times that, 60 centimeters. Or in other words, magnification is 3 times, or magnification is di by do. So di is image distance divided by object distance is 3, and we also get that di is 3 times do. But because it's a negative, or it's a virtual image, you've got your di as a negative sign there. Okay, focal length, it's a concave mirror, so that has to be positive. So this is your lens formula, where 1 over di plus 1 over do equals 1 over f. Important thing, put the minus sign there because it's a virtual image. So in place of di, I've just put 3do so that I don't have so many unknowns. And then I just do negative 1/3 do plus 1 over do equals 1 over 80. Then do is a common factor, so I took that out. So what is left is negative 1/3 plus 1. Is equal to 180. So 1 minus 1/3 is 2/3. And then I just solved this, and you end up with this answer, do is 53.3. So that's how you get that. And then my next question was question 2D. So when you do this diagram, so over here you've got your object and you've got an inverted image which is on the other side of your lens. So this is inverted. Okay, so the question was, what can you do to modify in order to get an image that is enlarged and upright? The moment you see enlarged and upright, that has to be a virtual image. And you get a virtual image in a concave lens when your object is very close to the lens. Okay, that's like your magnifying glass. Okay, so for your magnifying glass, so what actually happens is, if you have an object very close to the lens, when you draw your thing, it goes like that. So you actually kind of produce it backwards and you get your magnified image like that. So what did we do? So a few things that can be done is move the object closer to the lens, or keep the object where it is but move the lens closer to the object. Why? You want, if the focal length was here, then you want the object closer than the focal length. So you get your enlarged upright image when your object distance is less than the focal point. So you want a small object distance. Or you can use a very thin lens. So the thinner the lens, the bigger the radius of curvature. So if your focal length is like beyond where it is at the moment, then you still get that sort of an image. Or you use it of a different material, transparent material of course, but the refractive index is different. It has to be less so that the light will bend less. Okay, and that's the answer for that.